Alright, so without further ado, let us look through the CSEC chemistry syllabus. It is very late right now and I'm very tired. It is 4:20 in the morning. I've been studying all night, but we will try our best to look through everything for CSEC tonight. This will be a relatively long class, so it would be nice if you could subscribe. And I'm very tired, but we need to push for CSEC. Mixtures and separations. So unit 1, states of matter, atom structure, the periodic table and periodicity, structure and bonding, the mole concept, acid bases and salts, oxidation and reduction reactions. We have the electrochemistry, rates of reaction, energetics, and then we have section B, organic chemistry and introduction to organic chemistry, reactions of carbon compounds, large organic molecules, inorganic chemical metals. We have non-metals, water, green chemistry. We have the qualitative analysis. So we'll be going through each of these big concepts one by one. The three states of matter is solid, liquid, and gas. The three states of matter are solid, liquid, and gas. Most substances can exist in all three states depending on the atmosphere. For example, water is solid, ice is below 0 degrees Celsius, liquid water between 0 degrees Celsius and 100 degrees Celsius. Gas steam is above 100 degrees Celsius. So, the particular theory of matter, all matter is made up of particles. The particles either vibrate as in solids or move from one place to another as in liquids and gases. There are forces of attraction or repulsion between the particles. The particles that make up carbon can be atoms, molecules, or ions. An atom is the smallest particle that can be broken down by chemical means. A molecule is a particle containing two or more atoms. The atoms can be the same or different. An ion is an atom, a group of atoms with either a positive or negative charge. We can explain the nature of solids, liquid, and gases by looking at how the particles are arranged, how close the particles are to each other, and the motions of the particles, the strength of the attractive force between the particles. So we have solid arrangement of particles, regular pattern, closeness of particles, very close or touching each other. Motion of particles vibrate along a fixed point but do not move from place to place. Attractive force between the particles are strong. Then we have the liquid arrangement of particles, irregular, no pattern, no particular pattern. Closeness of particles, very close or touching each other. Motion of particles move slide each over each other slowly. Attractive force between the particles are weaker than in solids but stronger than in gases. Then we have gases, arrangement of particles, irregular pattern. Closeness of particles very far apart or far apart. Motions of particles move everywhere rapidly. There are almost no attractive forces between the particles. So going into explaining the nature of solids, liquid, and gas. Solids have a definitive shape and volume and cannot be compressed, squashed together. They do not flow like liquids. This is because a strong attractive force between the particles. Keep the particles close or touching each other. And we have liquids. Liquids have a definitive volume but do not have a definitive shape. And they can flow. For this reason, they can take the shape of the container in which they are placed. The force of attraction between the particles are not very strong, so the particles have enough energy to slide over each other. Liquids cannot be compressed, squashed very easily. This is because the particles are close together. We have gases. Gases do not have a definitive shape or volume. This can spread everywhere. This is because there are hardly any force of attraction between the particles. Their density is very low compared with that of other solids or liquids. They cannot be compressed because the particles are far apart. The next, which is 1.2, we have a lot of things to look through in this stream, but I will try my best to go through everything in this stream, no matter the consequences to my health. Please subscribe, guys. Very tired right now. I'm studying whole night. So we have diffusion. Diffusion in liquids and gases, the particles are in constant random movement. Random movement means that the particles go in any direction. The particles in liquids and gases are constantly changing direction and colliding with others. The idea that particles are in a constant motion is called the kinetic particle theory. Diffusion is the spreading movement of one substance through another due to the random movement of the particles. In diffusion, the overall direction of movement is from where the particles are more concentrated to where they are less concentrated. Diffusion in gas is faster than in liquids. This is because the particles in gases move faster than in liquids. So we have exam tip. Let's read that tip. If you are asked to define diffusion, it is better to give an answer about the spreading or random movement of particles rather than movement of particles from high to low concentration. Although the overall direction of movement of particles is from where there is concentration high to where it is low, some particles are moving in the opposite direction because the movement is random. Um, Going back to what everything here. Examples of diffusion: diffusion of potassium magnet (VII) in water. A crystal of potassium magnet (VII), also called potassium permanganate, is placed in water. The color of the magnet VII gradually spreads out through the water until it is the same depth of color throughout. This is because both the magnetite VII particles and the water particles in solution are in constant motion, bumping into and bouncing off each other. Then we have diffusion of gases. Hydrogen chloride and ammonia gases. A long glass tube is set up as shown in figure 1.22. The hydrogen and the hydraulic acid gives off hydrogen chloride gas, and the aqueous ammonia gives off ammonia gas. After a few minutes, a white ring is seen nearer on one end of the tube. The ring is nearer the hydrochloric acid end. We can explain the using the particle model. The hydrogen chloride and ammonia particle molecules are in constant motion. They bump into and bounce off air molecules and so move along this tube. So if you could see from the tube being illustrated right here, it meets at the middle basically. The white ring is near the hydrochloric acid end because hydrogen chloride is a heavier molecule than ammonia acid. Heavier molecules move more slowly than lighter ones. Then we have osmosis. Osmosis is a special case of diffusion. Osmosis is the overall movement of water molecules through a selectively permeable membranes from where the water is at a higher concentration to where it is at a lower concentration. Osmosis can be demonstrated using the strips of pawpaw fruit placed in distilled water or sugar solution, i.e. as figured out in 1.23. The contents of cells of fruit can be thought of as being a solution of different substances in water. The cell membranes is selectively permeable as illustrated in the diagram. I will give you a couple seconds to look at it. In distilled water, the strips become longer and more rigid. This is because number one, the water outside the cell is more concentrated than inside the cells. Number two, water passes into cells by osmosis. In sugar solution, the strips become shorter and softer or flaccid. The water outside the cell is less concentrated than the water inside the cells. This is because there is sugar as well as water in solution. Water passes out the cells by osmosis. Some uses of sugar and salt. Sugar or salt are used to preserve food. They stop bacteria and fungi from growing. The cells of all organisms depend on water for survival. Foods with high concentration of sugar or salt remove water from bacteria or fungi by osmosis, so they die. Then we have change in states, which is melting solid to liquid, liquid to gas, gas to liquid, and liquid to solid. So energy and changing of states. So melting and changing of state, which is energy and changes of state. In melting and boiling evaporation, energy is absorbed, which is taken in. In condensing and freezing, energy is released or given out. Or given out. So we have heating and cooling curves. Figure 1.32 shows how the temperature of solid changes when it is heated slowly to form a liquid and then a gas. We can explain the shape of the curve using ideas of energy. Heat transferred to the particles. AB, increase in heat energy increases the vibrations of the particles in the solid, so the temperature of the solid increases. BC, the force of attraction between the particles are weakened enough so that the particles slide over each other. The temperature is constant because the energy is going in to overcome the force between particles instead of raising the temperature. The substances melt. CD, increasing the energy increases the movement of particles in the liquid, so the temperature of the liquid increases. We have DE. The forces of attraction between the particles are weakened enough so that the particles move well away from each other. The temperature is constant because Energy is going in to overcome the force between the particles. Instead of raising the temperature, the substances boils. So let us go into our new term, which is sublimation, which is very interesting as a matter of fact. Sublimation. So sublimation is the direct change of a solid to a gas on heating without any liquid state being formed. It also refers to the direct change of a gas to a solid on cooling without the liquid state being formed. For example, solid carbon dioxide changes directly to carbon dioxide gas when heated.